map within that projection, the sizes of the circles do change compared to the globe, right?
Yes, but they're all representing the exact same distance x, right? And they're just doing a visual scaling difference, which is the difference between the Gleason's projection and the globe, right?
But then, but then you're not referencing the distances within the projection. You're referencing the original ones. No, when you say they're the same, you're talking about like when you deep project the projection, then you get the same distances as the globe. Of course, that's where the projection comes from.
Right, but that's all the Gleason is capable of doing, is giving you the globe distance. So to say, right, that this globe distance is different than the other globe distance is kind of silly.
No, but to get the Gleason's map to give you the same distance as the globe, you have to convert it back to sphere to get the correct distances.
No. Have you tried to do it, Bacon? Have you compared it at all?
Oh, you're saying there's a way to get distances using the EA map that matches the globe without
Yes, all those things. Right. So it does give you distance. There is a distance scale, but the end result will always match the globe. So it's like, does that really help the flat Earth argument? No, but it helps my argument when I understand that all maps are projecting the same coordinate system.
Let me see how you do that.
Right. So those two screenshots are from the patent, right? And then there's a little video. Actually, hold on. Let's just take this. So the longitude lines are exactly equal. You can measure longitude from the center to any point on the map to give you exactly the globe geodesic distance, right?
Same distances from the North Pole are the same?
Yeah, that's just the basic principle of an azimuthal equidistant projection. Okay.
Yeah, one centered in the North Pole. Yep.
Right. So that means that you can compute longitudinally any distance, right? Just using longitude. It's only tricky when those the outer circles of the latitude, right, where they get strangely skewed according to those circles that I put in there.
Yeah, your last image is broken to me, but I think I follow what you're saying.
But so those circles represent the same distances, right? And when you put them on there, they're literally like the outer circles on the bottom are just visually stretched. That distance is the same as the north, right?
Yeah, if you're talking about what they represent, then yes, the A map represents the globe. So of course the distances the A map represents are the same as the distances on the globe.
Oh, exactly.
But we're not talking about that. Like we're not talking about distances it represents. We're talking about the distance if you treat the A map as that's what the Earth is, and then you take the distances directly from the A map without.
But so how are you getting distance from the A map then? Are you just visually comparing a line without using the legend or the approved patented method to determine distances based on latitude and longitude?
Well, if the A map was already a correct representation of a flat Earth surface, then you wouldn't need to do any conversion. All you need is a single scale for the whole thing.
Right, but how could that be true if all the maps are projecting the globular coordinate systems and producing the same geodesic arc distance, right? The same thing as Google Earth or whatever method we compare it to, it'll always be the geodesic arc, right?
Oh no. If the Earth is not a sphere, then there should be at least one projection that turns the sphere into the correct flat map.
There's no way you'd have a projection that would do that, right? The projections only work because of the inherent longitude and latitude coordinate system, and between those can use projections like equidistant or equal area to maintain the, what do you call it? The structure. That's all. The distance, maintain proportionality.
Oh no,
you can use a globe to measure the distance to scale, like a globe, a desk globe.
Mm-hmm.
It is to scale for the distance.
Yeah. Well, just to answer Shane, let's say you made a drawing for me in a piece of paper, and then I scan it on my computer, and then I wrap it around the sphere. So I use my website to wrap that drawing on the sphere, and then I use just a random projection. Now, that sphere is not the correct representation of your drawing. It's all distorted. The distances are changed within that sphere. But if I apply the correct projection, I can turn that sphere back into the original drawing.
Absolutely.
Yeah, so that's the point. If the Earth is a flat plane, there should be some projection that maps it correctly to the right flat Earth map.
Well, yeah, but then that map, by definition, wouldn't adhere to the globular longitude and latitude, right? Because that's what makes the projection seamless equal area transforming in between without losing any data. Because of that coordinate system, that's how they're allowed to do that. I guess if we had a map that didn't use that, then that would be correct. But there isn't one that I know of. But my whole point, right, is to say that because we know this map is just the globe projecting and it does do accurate distance scaling, I see a lot of people comparing distances on the two maps like it proves something, and I'm just curious what they think they're doing.
I think they're saying, well, if this map is what Earth is, then this distance is no match reality.
But like, what flat earther would say the Earth is actually the exact same as the globe, proportionately flattened out, so that it skews the globe distance? Like, no, that's crazy. Obviously,
Well,
that's the globe.
yeah, some flat earthers won't accept that the A map is a globe projection.
Okay,
Some will claim that that's actually the accurate flat Earth map, and the globe came from the A map, the Gleason's map. That's where they got the globe from. So it's exactly the same projection, but in reverse.
so then the plan is to trap those flat earthers in this sort of debate. Then
No, I mean you're asking why people say that. I think they say that because they're talking to flat earthers that believe that.
yeah, sounds valid. But you see what I'm saying, right? Like, that's why I don't bother. But you can do the math,
Yeah,
get the distance. It's the same exact distance. There's nothing that's different, right? It's it should be a giant concession. You shouldn't be like trying to poke holes in it. But
yeah, it's the same distance if you treat the A map as a projection of the globe. Then of course you get the same distances as the globe.
actually, Bacon, right? It works because both the globe and the AE are projection.
The projection from what?
That's the good question, right? Otherwise, it wouldn't work that way. You wouldn't be able to translate without data loss intermittently through the same, data and all the different projections because they all use the inherent, curved geodesic longitude system or whatever longitude lat system.
Latitude and longitude system is a polar coordinate system who is made for a sphere.
I know. The border longitude came around and made sure of that, right?
A map is a projection of the globe.
Yeah, I know that people say that.
I show you. I can do it from anywhere in the world. I can produce you an A map from anywhere in the world.
I know.
It will
I agree.
from the globe. From the globe.
Or from another map.
I didn't project the globe. I just use the coordinate system latitude longitude with a spherical coordinate system. Globe is not a projection.
Right, but I can use the same translation into any map equally, including the globe. So whether the globe, the star, the Burr star, any other known map projection will equally translate that data back and forth to and fro with no repercussions, right? That only works when they're all projected using the same coordinate system.
Yes, and this coordinate system is a spherical one.
All the coordinate systems use the curved longitude latitude lines for sure, right? That would be the argument, I think. That's where I would stick.
Yes, so you agree. Latitude and longitude, they are angle to get the position of any point on a sphere.
They are globular in nature, 100% agree.
Okay, so all maps are projection from a globe. The globe is not a projection of itself.
Well, so all maps are projections of the same curved coordinate system. That's where I'm at. I think honestly you can say that that's the case. Otherwise, we wouldn't be able to translate into and from the globe so seamlessly, right?
From the globe.
Yeah, from, to, all back and forth, backwards, forwards, inside out.
I know the formula to project both. I show you I can do it.
But you're going to show me that I already agree with you.
Yeah. So all maps are projection from a globe. The globe is not a projection itself.
Right. I know that you have to say that. I understand, right? But my position is different. I'm just not going to keep repeating it. It's cool that you think that, though. I understand why you do. But like the main point, right, is that all these talks about maps when they're all projections of the same data, right? It's just a difference of visual linear scaling. So you're like, hey, my globe projection looks better than your globe projection, but they all display the same distance. That's the best you could do, I guess.
The problem with map, when you make it flat, is they will all time have a distortion. So all these cartographers try to show who has the bigger, who will have the projection that will be closer to not to reality, but to globe.
Well, it
This is
definitely
why.
is. The coordinate system they use is curved, right? I'll give you that absolutely. That's how they get the distances. That's how they secreted away those coordinates after 1712, and they lost all those people to figure it out, and then projected all the maps from there since then. But like what it really is is just celestial coordinates projected, dude. That's how they got all the geodesics when they did their wonderful surveying and matching the celestial sphere with the geoid and all that good stuff. But that's my explanation for why it's curved.
You don't need to have the star to verify that it's curved.
What?
You go peak to peak from mountain to mountain, measuring angle and everything. You do land survey, and you will have to map it on a globe to be at scale.
Well, no, since the 1911 American Log of the Triangulation of the Parallel, when they started, comparing it to spheroid models like the put forth Clark spheroid and whatever else they were trying to adjust to, they also tried to make adjustments to the longitude-latitude system that I'm referencing here, and that's when they had all those issues. So,
Okay, if you want. Anyway, you post by the distance map. You post your mathematic. I don't see any things in what you post that will give me the distance. So can you make one example of how to calculate the distance on your A map?
do you not believe that they're the same projection? I thought you're kind of arguing that, right?
No,
You
no,
already
no, no,
understand.
no, no. Not my question. Can you show us, lay down the math, how you calculate the distance between two cities on the A map?
Yeah, exactly. You use the
The
longitude, latitude, and you get the longitude, right? Just from looking at the map, you get the latitude by the ruler that lays over your intersection of that lat, and then you use the Greenwich time with your local time to actually determine what it would be. So that's how the instructions are written. That's how distances would be computed, right? All it does is accommodate for the southern latitude's concentric circle size.
I don't ask you the time difference. I want you to show me the distance between two cities. Take Santiago de Chile and Sydney, for example. It will make long line on it that we can see better to be not a squishy in a corner of near the pole. So take two cities, Santiago and Sydney, are where?
There's Stockholm and
And,
Sweden
and
using just longitude.
yeah, but and show the calculation and give us the distance that it will be between the two cities using the A map. You tell it's easy and just a switch off between one and another projection or globe. So please show it because
So you're hanging the whole argument on the Gleason's map not equaling globe distance?
no, I'm not arguing that. I'm asking you to show us how to do it. We are both dumb globers, so please educate us. Make an example, show us an example how to do it.
You haven't read the patent then?
I read it,
Did you?
so please make an example.
Are you denying the equivalence, or you're just trying to do some sort of weird gotcha to Shane?
No, because
Oh, did you have
on this,
specific cities? Did you want me to put it in a video? Did you want me to dress it up with a bow? Or do you want me to hold on? Let me just get a picture,
Demon,
get my map out, put it on for you. No, hold on, no worries.
demon. In the pattern, they tell how to make the time difference. There is nothing that tell how to measure the distance between two cities. So I'm missing something
You?
here. So I want to know how to calculate the distance between two cities, not the time difference or the longitude difference, but the distance between
So
two cities
you don't
using the
know
Gleason.
you don't know how longitude works? I mean, obviously.
Yeah, we said. I would say I don't know. I don't know. Tell me. Damon, if he say it works and it can be done, I want to know because I have tried to do it on a Gleason map to get the correct distance, but I cannot get it.
What's up, Rigel? What's up, Oscar? And Uber?
How's it going?
What's up, guys? What are we doing in here? Just mapping around?
Yeah, it seems pretty mappy.
Map this planet. Map this planet with Gleason's map. Map this planet. Map this planet with rock and roll.
With
Like
Walter
map.
is.
With
Map.
Bislin.
Map.
Is Shane here? Are you around?
Shane
Huh?
left
He
the building.
he was, but I think he
Oh,
got
he is.
schooled by some guy from France.
School. So like,
Oh,
so
he
when
is here.
hold on. So when I showed this, then y'all concede immediately and stop talking about dumb shit for perpetuity. Is that what I heard? Right?
It was a joke. It was a joke,
I
Shane.
can't confirm nor
Come
deny
on.
that, Shane.
Yeah.
Calm down, Shane. It was only a joke.
Sounded like
Yeah, we know the
Shane, I
French
have
can't do
a.
anything right.
Well, I just want to put the stakes clear so we know what is not possible, right?
Can I ask a quick question about your website or presentation?
Is that Mole Man? Yeah.
Yeah. Yeah, because it said that the furthest we can see is 3959 miles. Would that be accurate?
I mean, that didn't sound like a question, but yeah.
So when I see the sun when its GP is in Baja California in the summer, which is almost 6,000 miles away, what's going on there?
Would you say it's under 6218 miles or so?
It's roughly 5,800 miles.
Okay, well, how is that working on a globe? Is that a linear distance, or how is that past the radius you're able to see?
It's a distance on the surface.
Right, so you have a linear distance and a curved arc, correct?
No,
No,
distance
well,
on the surface.
let's back it up then. Okay, yeah. So 6,200 miles that you see. How are you seeing that past the radius again?
No, 5,800 miles.
For what do you mean 5,800 miles?
The distance to Baja California from northern Finland is 5,800 miles. And we see the sun 24 hours a day in the summer in northern Finland. And
Oh my
that's
God.
where the Tropic of Cancer is.
So that's your question? Sunlight, daylight distribution?
No, seeing the sun, the actual sun.
Seeing the actual, it's nothing to do with the 24 hours then? Or the daylight?
Well,
No.
it has to do with the 24 hours in a way that when I'm in northern Finland, the sun is directly over California or Baja in California, and I can see the sun. It's much further than 3,900 miles away, and I can still see it.
You mean where you are, right? Why don't you draw me a map? Because it seems like a very specific question.
Do you need a map to?
I need a globe map to understand distances.
No, I'm asking about flat Earth.
Yeah, maybe. No, really though, a map to show me what you're talking about.
Sure. Which can I take the AE map?
Yeah, it's all the same.
Sure. Okay. I'll just take you the copy of the AE map, and I can point you the places over.
I think all he's saying is that if the limit of our perspective, if we can only see 3,959 miles or whatever the hell it is, and he's saying that he can see the sun like 6,000 miles away from Finland to California.
Yeah. Plus the altitude, that's always also adding to it, because the sun is always also higher than the ground. I don't see why you need a map for the distance, but
the sun is higher than the ground.
Yeah, if the Earth is flat, then the distance from me to Baja in the summer would be 5,800 miles.
Oh my God.
But that's the baseline for the triangle. Just getting the hypotenuse, it's further away. The sun isn't on the ground, so it's even further away. But are you saying that I can't see the sun because it would have to be too far away?
No, that sounds retarded. I don't think I'd say that. But you can't.
Okay, so then
so you don't have daytime, right?
What?
So you want to get me to say that you don't have daytime? You don't see the sun? Right, that sounds retarded.
No, I think you're not even listening to what I'm saying. In the summer, we have 24-hour sunlight. We see the sun for 24 hours. And at one point during the day, the sun is directly above Baja, California. That's where the GP for the sun is. And that is almost 6,000 miles away from Finland.
Yeah.
So right. I'm seeing way further than 4,000 miles.
When you say much further, how much further do you think it is?
Well, at least 2,000 miles further.
Right. So what's 69.07 statute miles times 90 degrees of latitude?
That has nothing to do with the distance.
Of course it does. What is it?
That has nothing to do. You said that the limit of our vision is 39.59.
It's 62.18, which would be the linear distance, which would be represented by the same radius, right? Because why would you see a linear distance extending past your radius? You wouldn't. When you extend it to a 3D sphere, you have that linear distance into a geodesic arc, or did you, right? You following so far?
No, it's the limit of my vision, 4,000 miles. Can I see further than 4,000 miles?
Well, then go look at the math, bro, because it has limits up to 62.18 and encapsulated in that, unit circle that I used to trace the trig all the way through.
Okay, so when I asked you if the limit of my vision is 339.59, you could have just said, no, we can see as far as we want.
Well, no, that's retarded, see what I mean? Like, no, it is the limit.
No, it can't be, because if that's the limit, then how in the fuck can I see the sun when it's more than 6,000 miles away from me?
What's the difference between a linear distance and the curved distance?
What's the curved distance on the flat Earth?
My God, dude. All right, if you can see something 6,200 miles away.
A curved distance would always be longer than a straight distance. A shortest distance is the straight line.
It would be. Well, then how come on the globe Earth, 90 degrees
we're
of
talking about
latitude
the
of
flat Earth.
separation with 69.09 miles statute being literally applied gives you 6,218 statute miles between the North Pole and the equator.
Why do you bring in the globe when we're talking about your flat Earth idea?
Because this is exactly relevant. Now, do you understand the problem with the question yet?
No, there is no problem. The Earth is flat.
Of course,
and we can only see less than 4,000 miles, but I see the sun when it's 6,000 miles away.
Oh my God. Right, 69 miles per degree, right? You think that applies, correct?
What are the degrees on the flat Earth?
Well, in the north, they're identical, right? Latitude's the same, so no need to quibble about that. But you understand, 69.07 times 90 is what now?
What's that math for?
Well, if that's the distance linearly scaled, applying 69 degrees per mile all the way through, then why is that not the radius of Earth?
Why are you talking about the radius of the Earth when I'm talking about linear distance on the surface?
Exactly. And because you don't understand the question yet, we're still going to go around it. But what is that amount, right? Because on the Earth, on both Earths, right, just the Earth, that math holds out, right? 69.07 times 90 degrees of latitude, 6,218 statute miles. You agree?
Or what's that distance?
Do you even understand?
What is the distance? No, what is the distance?
Do you think that equals something else?
No, I'm asking what distance are you talking about? Are you saying that the distance from northern Finland to Baja California isn't 5,800 miles?
Your question revolves around the limit of how we can see, right? And you're saying that you can see about 2,000 miles longer than what I'm saying. So we started by computing the distance on the linear scale from the baseline, right? North Pole to the equator would equal about, or exactly 6,218 statute miles. Do you agree?
Why are you talking about that? Because that's not what I'm talking about.
All right, bro. If you don't understand what I did, right?
North Pole, and Baja California isn't at the equator.
So then you don't understand linear scaling, I guess, and you don't understand what a curved geodesic would be in this place, and then you don't understand the question at all, I guess.
Yeah, I mean, you're talking about the curvature when you're pretending that the Earth is flat. I don't see why.
Yeah, but see, in my model, the spherical limit of vision is curved. That's why I get to use, let's say spherical trigonometry. That's why I get to use 1 over arctangent to get the limit. That's how I get to use the math of the 3959 radius of the spherical visit, right?
Hold on.
So let's take it 2 steps back and go back where we started. The surface is not curved. No, but you're asking a question that revolves in this math specifically, and you're discounting that we want to talk about math first. Like, it's kind of crazy.
No, I'm asking about the distance first.
Okay, well, on the Earth, right, if it is 69 miles per degree, and there are 90 degrees separating North Pole and the equator, what would you deduce the distance between those two things are?
10,000 kilometers.
Okay.
That's the definition of a meter. So now, is the distance from northern Finland to Baja California 5,800 miles on your flat Earth? That's what Google Earth gives me.
There you go, 10,000 kilometers. So exactly that. That would be the linear distance, right? How on your spherical Earth, first of all, are you seeing a distance linearly extending past the radius at all? And then secondly, why would that not apply to the same spherical distance that I'm also invoking using the same math, right?
I'm not looking on the distance on the surface. I'm looking to the sky.
What's up, dogs?
Yeah, I'm just really confused by why you're dodging this, Shay. Like, you say there's a limit to vision of 4,000 miles, right? And
Yep.
there is an observation that is greater than 4,000 miles, so we can see something further than 4,000 miles. If you map that out on the flat Earth, it doesn't work. If you map that out in the globe, assuming no limit to our vision, then it does work. Like, I don't understand what you're talking about. So, like, he's saying that this does not work on a flat Earth if you have a limit to your vision of 4,000 miles.
Like, I understand the confusion, right? But the resolution to that starts with this problem, which is present in both, right? So, 6,200 linear miles, how does that work? How is that not the radius of Earth on the Earth, then?
Yeah, so the problem is you keep asking this same question of like, this is the radius of the Earth, whatever.
No.
But you're not explaining how that deals with the issue at hand. of seeing further than 4,000 miles.
You know, I'm definitely going to deal with it, right? Because I have the answer. I'm
Well,
trying
do
to
it
bring you
straight away,
guys
Shane.
through it.
Don't like ask us red herrings. Just actually give
Red
your
herrings.
Hey,
How
Doug,
come? How
let's,
come?
let's allow people to finish.
How come the radius of Earth isn't 6210? Any glober, someone, anyone,
But that's reversing
anyone.
the burden here. Like you're being asked a question, you can't then ask us about our
This
model. You need
this is
to
the exact
deal with
distance.
the problem that's been given to you.
Yeah, like I need to dance through hoops for you. Like I already have the answer and the understanding. However,
Well, what's the answer and understanding then? Is it asking us questions about the radius? Or is the answer and understanding something that you can lay out as an argument? Because right now there's an argument put in front of you that would falsify the either distance that we can see
only through massive
or the flat
misunderstanding.
Earth.
So I'm not too concerned. Hold on, something's
Well, go
playing.
ahead and correct us and tell us what we
I'm
don't
trying.
understand.
I'm trying, but you
No,
guys
no,
don't
you're
understand
asking
quite a
questions.
bit. So I got to start at the beginning.
You're asking questions. Don't ask questions. Lay out an argument.
Oh, fucking dude, that's the video I was playing. Yeah, so the reason, right, is exactly this relationship. He says you can see it up to 6,200 miles. That is represented in the math, right? That is the linear distance. I keep saying linear because it matters. Until some glober can tell me why that's not the radius of Earth, then we can't explain to you the solution of why that isn't a problem.
Yeah, but we don't understand what that means. Why we have to have anything to do with the radius of Earth when
Well,
we're making critique inside of your model. Do you understand what that means, a critique inside of your
yeah,
model?
yeah, I understand words.
Okay, what does it
many
mean?
things,
What does it mean?
Many
What does it
things.
mean?
A
What does it
critique?
mean?
What does a critique mean?
Inside of your model.
In a, listen, docs. I don't really have to sit here and listen to any shit from you, bro. However, if you
No, you
guys
don't
want
have
to
to.
figure
I'm
out this
asking you
answer,
if you
right? If you guys want to figure out the answer, you should figure out why the radius of your spherical Earth isn't 6,218 miles. That'll help you
Right,
tremendously.
I'll answer the question. So the answer to the question is that an internal critique is when we assume that your model is correct, and then we try to apply some observation to that model. And then if it works, then your model has been validated. But if it doesn't work, then we have critiqued your model. We've come up with a problem inside of your model. So
Well, no,
your
it
model
works. It
claims that you
works
can only see
entirely.
4,000 miles, and then there's an observation of something over 4,000 miles. And assuming a flat Earth, how is this possible?
Yeah, there is no observation over 4,000 miles. That's the answer. But
You were just giving
because you don't understand like the math behind it and the difference between spherical and linear, you guys are having a massive misunderstanding, and that results in this kind of chaos, right? So I'm here to help you out.
We're assuming it's not a sphere, so why is it about spherical? Why do you invoke spherical when we're assuming that it's a flat Earth?
What is my position then?
Your position is that the Earth is flat. We're using a flat Earth map. Why are you assuming spherical?
Nope.
Are you
not
admitting
using-
the Earth is a sphere?
Nope.
Why are you
Nope.
invoking spherical?
Well, you should probably go read some of the backup stuff that puts forth the position in the first place to back up why I'm using the spherical math. When I took it back, actually, because I can derive that optically, right, through the Rayleigh criteria and resolution limit.
So why are you invoking
Using those two,
the
shut the fuck up.
Are you just saying that we see
those two
things
together,
in
I can
curved
derive the
geometry?
fucking. I see it, dude.
Are you just
Dog,
saying that we
let
see
him
in
answer,
curved
dog.
geometry?
You can't interrupt him halfway through his comment, even if you don't agree.
You're right. I'm sorry, Trouble.
Yeah, I couldn't
So-
get to the mute button, so now we don't have a conversation. Good job, Doc. Start dancing.
Damn.
You got what you wanted. Start dancing. Make us happy now.
Demon Stride, maybe you should, I don't know, not be.
Hey, fuckface. This ain't your server. You don't get to decide who fucking talks here. So when told like, hey, good job fucking killing the convo yet again, you want to be a little bitch about it, you get a lot of server mute and then this.
Come on.
This shit pisses me off, man. Here we go. We shut the flat Earth up. Silence. Ah, perfect. Exactly what a Discord.
Because we already know they have nothing from our point of view. And, yeah. But they've gone to all this effort, I think, of making this start of a model, whatever you want to call it. So,
Hi. So yeah, I just got in. Did I miss Shane proving?
Yeah, you missed fuckface McGee interrupting everything. So we didn't get any proofs or anything because he decided it wasn't worth talking to him.
Oh.
Well, it's a nice excuse, but yeah, Dogs does find him mute, but Shane doesn't have anything anyway.
So I missed Shane's big
Just do your own research. Yeah.
mathematical his mathematical whatever of
With
stars. Well, dang.
well, I think what we're missing is, like, we think Whitsett is a big shot in Flat Earth, and he is, but he's not with the OGs. Not with Nathan Oakley. Because they've had the attitude always that you never try to describe Flat Earth, you just stay with destroying the globe. And these guys are going against. So I don't think that they're getting a lot of outside, they're getting a lot of pushback, I think they're getting even from inside the Flat Earth group, I would imagine.
I thought the OGs were originally about showing where Flat Earth was better, but they kept getting shot down by the irrefutable truth, and so they stopped that because it was too hard to hold a position that was obviously false. But you could always pick at the evidence for
Yes.
globe. I think this is just because these guys are, as you say, relatively new to the scene. They haven't been shut down hard enough yet, so that'll come. Particularly if they're now pushing something new, which is obviously false.
Yeah, see, like, the original god of, the daddy of Flat Earth was Mark Sargent. But I think once all that ended, I mean, I suppose he still is, but who's he hang out with, Jaren and all that crew? I think, I'm not sure.
Well,
I don't watch any of them anymore.
well, Mark Sargent, he did come up with the I'm Mark Sargent on a T-shirt, and it's always important to have a name remembrancer.
Like producer.
Yeah, well, like flat out, you know, he went into this and he made some inventions, you know, to remember your name, and he's got some really clever videos on that, you know, name remembrancer. But yeah, you know, and this whole invention kind of goes back to Mark Sargent, you know, so he is the OG, I guess, one of the OGs.
Yeah. A few of them died. And there were a lot of OGs that weren't, like, they were in the background. They didn't have shows of their own, but they hung in that group. And then
Let
the
me
Flat Earth split into
find.
different groups too. You know, there was a religious group, a non-religious group, a group
Yeah.
that knew that there was something going on in the sky, especially in the south, and a group that just pretended it didn't happen. Um, like Mark Sargent, you know, you look north and you see the spiral. You look south and you see the southern one. There you go. Explained. Going anti-clock. Oh, actually, they don't explain why it's there. They just explain the counter rotation. And they forget all the fact that it shouldn't even fucking be there in the first place, and they won't discuss that. It's just no, it's the rotation. We'll explain that. It doesn't explain anything on a flat Earth. What the fuck?
I'm looking really quick for Flat Out's
And of course,
name remembrancer video.
I think Sargent is a dome believer too, whereas some of the other ones they went to the infinite sky sort of thing. And now these guys have got both. They got the dome and the infinite sky. It's like fuck it, we couldn't decide, so we'll just take both.
So we got Flat Earth Tech, name remembrance tech for FE nudists. Let's see if I can find where he. Oh, the Flagier. Yep, I remember that. Man, I put some hot sauce on my tuna salad, whatever. Whew, boy.